So for today, we'll be doing the first half of chapter 4, sections 1 to 3. And so it deals with today exponential equations. Right? So for example, this equation, population is given by 6 times e to the 0.012 t. This is the equation that would model world population growth based on the year 2000, which is when we hit 6 billion people. So t is the number of years after the year 2000. Right? So my question then is, how many people in billions will be on the planet in the year 2050? So 2050 is how many years after the year 2000? 50. And so population will be given by 6e to the 0.012 times 50. Right? So on the calculator, you should have an e to the x button, which is probably a second function right above the ln button. Right? So you want to be able to plug this into the toy and tell me how many people will be on the planet. And that number, again, we will be in billions of people. And the answer is
on my calculator, the e to the x thing, I pressed it and it says 1.
probably because your calculator works backwards.
Do you want a rounded number or?
Yeah, nearest 10.
I have 2.9.
How much?
I have 10.9.
10.9 would be better. In Jason's world, we just killed off over half the population. If you guys think,
Yeah, that was actually intentional.
Okay.
It's 6 to the, wait, so what's e?
E is e to the x. E is a number like pi.
Because I have 6, I just don't have the e, that's why I have 6 e, but I don't have e.
So e is a number like pi.
Oh, there it is, okay.
Right.
Okay, so I have 10.9 now.
Yeah.
So how would we work that out for those of us that don't have calculators that are also
You need to get a calculator. That is
That's the only way to do this trigonometry.
because you are going to need a calculator, because really in this chapter, we're not only we're going to have e to the x, but we're also going to be dealing with, in terms of taking the log and natural log of numbers, you need to have a calculator that can do those. Okay? So you need to find a better app or whatever, but you need something that can do e to the x, log, and natural log.
So you never want to use e as one of your variable placeholders.
Okay? All right. So you end up that in the year 2050, based on this calculation, that there will be only 10.9 billion people on the planet. We are currently over 7 billion people on the planet. And growing. Okay. So you figure 2050, which is only 36 years from now. So when you guys are getting close to retirement age, there'll be basically 11 billion people.
I would have probably been retired for 20-ish years by then.
There you go. All right. Now, after all, we've been in class now for basically 2 hours. which means in that time we've added over 16,000 people. Yes. Okay. See, a little bit more than 16,000. And that is the net number. That does take into account deaths.
What's the .0112?
Rate of growth.
0.12.
It'd be 1.2% rate of growth
Oh, okay.
for the population. This is the point.
You need a good old fashioned world war.
E is a number like pi.
Is pi.
It's a number like pi. It goes on forever and ever. It's
What's the actual number?
2.7.
What is the-
8, dot, 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 dot.
What does it stand for? Like what is, like
Yeah.
the symbol is pi, is
Pi is pi.
right. Is it, I mean, is this have a name, is what I'm asking? Like is it, or is it
Just
just
E.
E?
Yeah. Right? Okay. So this chapter deals with exponential and then logarithmic functions. So the first few sections that we're doing today deal with exponentials. So population growth is exponential. Okay? So basically, in the difference between an exponential and linear growth, so you've got a linear versus exponential. So linear growth is just that. Linear growth is linear. Straight line. That's a linear. Exponential growth would then be more of it on a graph that looks something like this. Right? So linear is you're growing at a constant rate, or growing by growth by a constant amount. So basically, in terms of linear, it's always the same slope, right? Exponential, it's now by a constant rate. So in terms of our population, you got that as the base is getting larger, the more that we're adding more and more every time frame. Okay? So constant amount, constant rate. Okay? So maybe then you get, well, how do you decide if it's linear or is it exponential? Right? So for example, if I had something that looked like this, we got x, we got f of x, or whatever you want to call it, y, doesn't matter. 1, 2, 3, 4. So something like that. Right? So in terms of the first set here, really you got that the difference here each time is that it's 5, right? So this would be linear, okay? Whereas this one, in my difference here each time is changing. Okay. And so there's some kind of exponential type thing happening. Right? Right? Change it in terms of exponential growth. Right? So, for example, let's look at an example function, y equals 2 to the x. Okay? I want to know what does that look like in terms of a graph. So let's graph it. So let's pick some numbers for x. And so let's do 0, 1, 2, 3. What is 2 to the 0 power? 1, right? 2 to the 0 is 1. What is 2 to the first power?
2.
2. What is 2 squared? 4. And then 2 to the third will be 8. Right? So when x is 0, y is 1. When it's 1, it's 2. When it's 2, it's 4. And when it's 3, it's 8. All right? So we get some points that look like that. Right? Now, what happens when we go to the dark side? So -1, -2, -3. What is 2 to the -1? Now, if you got the toy, you can figure it out. The toy can do it.
Wouldn't it be like 1 over 2? Or
It is like 1 over 2. Because a negative exponent means 1 over that thing to the positive exponent. So it'll be 1/2. 2 to the -2 is going to be 1/4. And that will be 1/8. Or on the toy, you would end up at 0.5, 0.25, 0.125 in certain decimal
so does that mean y never hits 0?
It never hits 0. So if I go and graph this then, my graph is going to look something like that. Basically, that'll be true in terms of the shape for basically every exponential, as long as this number is larger than 1. They're all going to basically look like that. So my general equation then will be y equals b to the x. Okay. And as long as b is greater than 1, they all basically have that same shape. You know, the bigger the number is b is, the faster it goes up. But every one of those would have that point in common. The other, any number raised to the 0 power, with the exception of 0, is 1. So in terms of graphs, then, what would that look like?
It's like flipped.
It is like flipped. Same graph, just spun about the x-axis. And just put it up for comparison. Let's put this one up here too. This is y equals 2 to the x, okay? Okay. So the black one is y equals minus O to the x. So really all it says is take all the numbers we had before and multiply every number by -1. That's why it flips it about the axis, okay? Well, how about this graph? What does that do to my graph? It's going to flip it the other way, okay? So this one is going to take my graph and it's now going to run like that. So I can flip the graph about the x or the y.
So sorry, negative, she gets it to negative x, that is, that one flips that way then?
What?
Is that what, if you have a negative 2 to the negative x, are we doing that right?
No, we're not going to do
I
that.
mean, but that's, is that flipped to this on the x-axis?
It would take this and then go this way. We'll
Right.
just bring this down here if I did that, all right? All right. Let's see. How about this one? What's that going to do to my graph?
Is there a y adjustment?
What?
Yeah, like it moves it up on the y.
Yeah. It's going to take my basic graph, which we had before, and it's just going to take everything and move everything up 3 units, right? So if I graph this one, right? Now, if I want to do a quick graph of these, as I said earlier, the point that all of these have in common is this point right there. They all basically have this shape, okay? So all I have to do if I want to get a quick graph is figure out where does that point go. Once I know where that point is, I can draw in the shape, okay? So what happens with this one is that this takes my point, which was here, and it moves it up 3 units. It also takes this boundary line, which was at the x-axis, it moves it up 3 units. And so now we get our graph, which will look like that. Right? So everything goes up. My point and that boundary line, which is called an asymptote, goes up with it. Okay? All right? What happens if I wrote this as 2 to the x minus 3? What would happen? It drops at 3, right? So I can move the graph up, I can move the graph down. All right? Okay? What happens if I do this? What is that?
Just gonna make the curve steeper, isn't it?
No. Not going to change the shape of the curve as far as the curve. It's going to move the curve. The question is which way does it move the curve? No.
Then it would go forward to the right.
It will go forward to the, what doing?
Left.
Left is correct. Okay? Again, my key point we said was 2 to the 0 power because that's always 1. And so what you asked is, okay, when will x plus 4 equal 0? Well, that'll be at negative 4. Okay? So this is going to move my point, which was here. It's now going to move that point over here. And then we draw in our shapes. Right? So the thing about this and the way it works is the up and down makes sense, right? Because the up and down goes with the sign and the number. The left and right are opposite of what you would think by looking at the equation. Okay? So, if I were to graph y equals 2 to the x minus 3, what does that do to my graph? It goes 3 to the right. Okay? So let's put that on here. And so now my point is over here. And my graph is going to look like that. Okay? So, alright. So, given something like this, after I think in terms of next week, and there will be a quiz, you're going to get something like this. Graph. There. So graph that. Y equals 2 to the x minus 2 plus 5. Right? And again, we're just doing a quick sketch of this thing. Right? And what would that do to my graph?
Can I go over 2 but not 5? Again, you can back up your one like this on next week's quiz.
So your curve would be over in the upper right-hand quadrant, right?
So, first off, what does the x minus 2 do to my graph? It's going to move it, which was here, and moves it here. What does the plus 5 do to my graph? Moves it up 5. So it's going to put that point there. It's going to take the asymptote line, and it's also going to move it up 5. And so my graph is going to look something like that. Right? Right. So it's going to take my graph, and it's going to move it. So we can take our graph, we can move it up, down, left, right. Okay? So you think in terms of exponential and things that are exponential, you can look in terms of compound interest. And so a sub t equals a 1 plus So in this equation, a sub t would be the amount after time t. A, little a, this is the initial amount. So how much money did you drop into the account? Okay? R is going to be the rate, so whatever the interest rate might be. Okay? K is going to be in terms of the compounding. Okay? So is it monthly? If it's monthly, it would be 12. If it's quarterly, it would be 4. If it's semi-annually, it would be twice. Annually, it would be once. If it's daily, it would be 365. Okay? And then T is the time, and that has to be in years. Okay? So the time must be in years. So if they gave you a question and they tell you that the money is left in the account for 18 months, you would have to convert that into 1.5. That would be
compounding?
no, for the T, the time. The time has to be in years. Okay? So again, if they give you months, you need to convert it into the corresponding time frame in years.
What's
Right?
the A stand for?
The initial amount. How much money did they throw into the account?
The little a or the big A?
Oh, the little A stands for initial amount?
Yes, little a is the initial amount. Big A is the amount you got after you left the money in the account for whatever time frame. Okay? Right? So you do this formula, compound interest. Okay. And so we'll do a question here in a moment. Right, so you get something like this. So how much money? Let's do $5,000. Positive. APR. After 2.5% APR. And let's see, this should be compounded. And let's do this monthly. After, let's do 5 years. Okay. So how much money would be in this account? You put in $5,000, 2.5% APR, compounded monthly, and we're going to leave it in there for 5 years. I don't know how much money. So first off is we need to write out the equation, plug in the numbers, and see what we get. So A is going to equal 5,000. 1 plus, well, what is 2.5% as a decimal? 0.025.
What is this number?
Wait, what about the sub T that is by the big A?
What?
What about the T that's by the big A?
Well, it's not divided, it's just A
Well, no,
sub
not
T.
divided, but shouldn't that be there? Or does that?
Don't really need it.
Oh.
Alright, so 2.5% as a decimal is 0.025, maybe. In there, okay? Compounded monthly means how many times a year? 12, okay? And now we get to the exponent. It's compounded 12 times each year for 5 years. So 5 times 12 is 60. So my exponent will be 60.
And we did that by 12 times 5.
Yep.
Yeah.
So you now want to take that and plug it into the toy. And you do that to the nearest penny, you come out at $5,665.01. Thanks.
It's much better if you put 5 million in there. Just saying.
Okay.
There's probably better places to look at 5 million too.
Then at 2.5%, yeah. Not a very good return on your money.
But that'd give you a decent, income to live on.
Oh, yeah. Well, yeah, you think about income to live off, and again, if you think about for you guys, is that if you, when you get a job and you work at a place that has a 401k type plan, that you want to start putting money in it right away. Because the thing about compound interest and the way it works is time is the key thing. The longer you have your money in there, the more you get the money. Okay? Yeah.
So
Same thing.
then the big A is that the 5,665.
Yeah, yeah. So barely after 5 years, your money will have grown by $665
And a penny.
and a penny. Okay? That's how much money you got in there. So you got $665 in interest. Okay? So in terms of exponential equations then, we look again in terms of a more general form of my exponential. And y equals a b to the x. Okay? All right. So the only number that's being raised to the exponent is b, okay? Because after all, it's a times b, whatever that may be. Right? So you get to the parable about the magic penny. You got a magic penny on day 1. After that, the amount of money you have doubles every day for a month. So which would you rather have? The magic penny and the amount of money you would have at the end of a month, let's go with actually a 31-day month, or $1 million up front.
Penny.
Huh?
Penny.
The penny. Okay? And the way it works out for the penny is you're starting out, it's going to be y equals 0.01, and it's doubling, and it's going to be 2 to the 30th power.
It's 31st.
Now it'd be 30 doublings.
Wait, why 30?
I think it said 31 days.
There's 30
Yeah, but
days
it's
away.
only gonna double 30 times.
Oh, okay.
Because there's one less.
31 days.
And so if you plug that into the toy, you find out that at the end of the month, you have on the order of $10.7 million. Given the magic penny. Unfortunately, I don't have any magic pennies with me today. Alright. Okay. There's other ones like that. There is the one where the peasant has a bet with the king, and the king has to take 1 grain of wheat, put it on a chessboard, but then has to double the amount of grain every day until he fills up, until you get to the last square on the chessboard. Which, of course, on a chessboard, you're now talking 64 squares, which means 63 doublings. And so by the time you get to the end of the board, the kingdom is bankrupt because there's not enough grain in the entire kingdom. Because 2 to the 63rd power would be very large. Okay? Okay. Right. So my general form is y equals ab to the x. Okay? So what if I actually want to determine what that equation is? Okay? And how this is working. All right? So, for example, I want to determine the equation. In the form of and we have 2 points. That's my first point. That's my second point. Okay. I got my 2 points. First point is point 1,4. The second point is point 320. Okay. Well, if I look at this, then my first point would give me this equation. 4 is equal to AB. Because after all, this is the y, this is the x. Right? Right? My second equation would give me 20 is equal to A, B, to the third. Okay? Okay.
So,
So what?
so X is acting as, I don't know how to put this in words.
Well, this is my x coordinate, that's my y coordinate, right?
Yeah.
So all I'm doing is substituting into my form, which is y equals ab to the x. Right? So I took the y out, I plugged in the 4, I took the x out, and I plugged in a 1, and I don't need a 1 there, right? Right? And then I do the same thing here. Right? Right? So let's look at this one first. I can take this equation and I can solve either for A or B. Doesn't matter which one. Well, let's solve this for A. Right? If I take the first equation and solve it for A, Well, I'm going to divide by b, and so 4 over b is equal to a. Right? All right? Everybody fine with that part?
Divide by b, just brings it over there.
Yeah.
Yeah, just multiply, right? Yes.
Why do you want to find A? Just cause?
I can do one or the other.
So you can find B or A?
Yeah.
Alright.
Either way, they're going to look basically the same. In this case, all right? So now what I'm going to do is I'm now going to take this here and substitute it in there for A. So now if I do that, we get 20 is going to equal 4 over B times B cubed. Right? Right?
So, explain to me how this makes sense, 'cause
All I'm doing is substituting
why?
because I need to find out what A and B are. And I can't do it if I have two unknowns, right? If I have only one variable, I can solve for B. If I have two variables, not much I can do with it. Okay?
I think my brain died.
You're-
I don't know.
Yes.
Okay, well, so you know how the first equation, it doesn't have, like a degree because it's 1?
Right.
So what would you do if, like, in that first equation it does have, like, say it's like the 4th power or something, would it be 4 over b to the 4th power, and you just put it in like that?
Yeah.
Okay.
Right. All right. Well, what is b to the 3rd over b? What is b to the 3rd divided by b?
1. B. 0.
3.
X.
B squared.
B squared. B to the 3rd divided by b to the 1st gives you b squared. Keep the base, subtract the exponents. 3 minus 1 is 2. Okay. Well, now I want to solve that for b. The opposite of multiplying is going to be to divide. Divide this by 4. Divide that by 4. B squared is going to equal 5. B is going to be the square root of.
Doesn't it have to be plus or minus?
No, that would be just plus.
Why?
Because we're talking in terms of a function and we don't want plus or minus. We just want the top half. Right.
Just makes so much sense that it doesn't make sense at the same time.
So if we had done this the other way and just decided to start with the 20 equals a b cubed, we should end up with the same thing.
Yeah. So we know what B is, which means we now know what A is, because A, we said, was given by this. So A is going to equal 4 over the square root of 5. And we can now get my equation. Okay? So my equation is going to be y equals 4 over the square root of 5 times the square root of 5 raised to the x. Again, the numbers didn't work out quite so nicely, but the one you have in your homework, the numbers work out to be nice whole numbers. A little bit better numbers. grammar problem.
Can we do another one?
So once you get
Can we
B,
never do another one again?
No.
so once you get B, then you have A and B. Then you can plug it into the
General form, yep.
Okay.
Yep. Okay. Right. So my equation being in the form of y equals AB raised to the x.
Wait, it's a square root of 5. So that power inside this thing.
Yeah, just the square root of 5 is being raised to a power.
That's known as general form.
Well, my y equals AB to the x that I had up earlier. Okay?
I wanna say I'm lost, but I don't want to be taking up what I thought was class.
Alright, so, in terms of, a little different notation, like this, but A sub t is the amount at time t. We saw it earlier, or just a little bit different notation. A naught is going to be the initial amount. K is either the rate of growth, which would be positive, or rate of decay, which means it would be negative. And then T is the time.
Is this in years also? Like always?
Okay?
Wait,
So now
what's-
we're going to talk about my equation I had on the board earlier. Population equals 6e to the 0.012t. Was an equation in this form.
You said the T is not necessarily in years?
Not for this one. But if you're talking money and compound growth, T has to be in years. Yes?
So this is like the same as the first thing we did, the
Yes.
population. It's just a
Yeah.
different form.
Yeah.
So why have two? So
One
just
of them dealt
have
with
one.
money.
Okay.
Okay? The other one with compound interest for the money one. Okay? All right. So this is either exponential growth or exponential decay. The only difference is that the sign on K, whether it's positive or negative. Okay? That's the only difference between the two. So, for example, you get something like this. Something like that. I started out initially with 100 grams of element X, 20 hours later, I have 70 grams left. I want to know how much will be left after 100 hours.
So is X being used as part of the equation?
Now, element X is just element X. It's my,
Okay, because I don't even know who X is anymore.
That's why you should take it.
It's got a lot of different options, apparently.
There should be a video left for
Thank you.
that. Q.
are you better?
Sorry.
All right. Now, in terms of this type of problem, it is a two-step process, okay? We need to first find out what is the rate of growth or the rate of decay. So we got to find K value first. Once we know K, we can then answer my questions. So the process here is, we know that A naught is 100.
What's
That was-
that called? A what?
Naught.
Knots?
Not.
Not.
A sub 20 was 70. Right?
Wait, wouldn't that be K? Or is that what we're trying to find?
We gotta find K first. It's a two-step process. And then A sub 100 is what we want to find. That's my unknown. Right? So, in order to do this, we need to first get the K value. Once I know the K value, I can then get my answer. Okay? Again, my general form of the equation was that A sub t equals A naught e to the k t. So I can take these first two sets of numbers and get the value of k. So let's plug those in. So we get 70 equals 100 e to the 20 k. Okay. All I did was plug in my numbers. Okay. After all, kt is the same thing as t times k, and we generally we write the number in front of the variable. So that's why I wrote it as 20k. All right. Okay. I want to solve for k. Well, what's the opposite of multiplying?
Divide by.
So we divide by 100. 70 divided by 100 will just be 0.7.
When we're doing these, do we typically want to use decimal and not fraction? Like,
Decimal.
does it matter?
Either way, depending on what toy you're using and what it's going to understand better. Right? All right. Now, I want to solve for k, but k is an exponent. How do I get to it? Well, no. Everybody, if you look on the toy, right, you notice where you got the ln button and the EDX and they're paired up. You look on your calculator, you see ln is probably on the button and right above it is e to the x. Alright, so on the toy, try this. What is the natural log of e to the fifth? What is the natural log of e to the fifth?
Five.
5, right? If you do the natural log of e to the fifth, you will get 5, right? If I ask you what is the natural log of e to the 112, the answer will be 112. natural log and e's are inverses of each other, which means basically they cancel each other out. Right? So if I want to get to that exponent in my equation here, what I want to do to get to it is to take the natural log of both sides. So I take the natural log over here, we do the natural log over here, and so we get the natural log of 0.7. These two cancel, and I get 20k. Well, what's the opposite of multiplying? Dividing. So we divide this by 20, maybe 20. We divide that by 20. And we plug that into the toy. And we get the value for k. And that number comes out to be a negative 0.0178.
I got lost if we're adding the natural log part, you said it cancels what?
Well, natural log and e cancel each other.
Are they opposites of each other?
Yes. And whatever you do on one side of the equation, you have to do on the other side, right? So if I do the natural log on one side, I have to do the natural log on the other
But
side.
it doesn't do anything to 0.7?
Well, we do. We're going to take the natural log of 0.7
Okay.
and then divide that number by 20. Right?
Wait, but isn't the natural log of 0.7
No.
What?
That-
But over there it was. Oh man, never mind.
You need to take the natural log of 0.7. That's what you got the toy for. Okay?
So
Right. Now that we know what the rate is, in this case the rate of decay, we can now answer the question, which is how much of this stuff is going to be left after my 100 hours. And so to answer the question, we would have that A sub 100 is going to equal 100 E to the minus 0.0178 times 100. And that would tell me how many grams of this stuff is left at the end of 100 hours. And you end up on the order of 16.86. Right. And with that, let's take a 10-minute break. Buddy, get up and stretch. All right. So in terms of so let's go back. In terms of money, we had A sub T equals A. Oops, sorry. Making use little a. So let's go back to multiplication. A 1 plus R over K to the KT. Okay?
So you
Again.
use this equation in terms of money.
Right.
Dealing
And we
with-
saw this earlier. This was my equation dealing with compounding. Okay? And I had it up earlier. We did that one question earlier with the $5,000 being deposited for 5 years. Okay? So we did. Right? All right. So you got this one, which deals with whether it's compounded again. K was how many times is it compounded in a year, so then again he gave each of the words annually, semi-annually, quarterly, monthly, daily, right? Well, then you get the other thing you can have is in terms of continuous compounding. Okay. And so in that form, my equation becomes this. A equals P E to the RT, which apparently is almost in the same form as my equation for exponential growth. Okay? So A would be the amount of money you would have. P is the principal. How much money did you put into the account? R is the rate. And T is the time frame, again, in years.
What is P?
Principal. How much money did you put into the account? Clearly, it's the initial amount. Right? Right? So, for example, we said if I had $5,000 at 2.5% compounded monthly for 5 years, we said the money grew to $5,665.01. Right? What would happen if I now had where P was $5,000, R was 2.5%, and T was 5 years. And now, if I do continuous compounding, how much money would be in this account? So A is going to equal 5,000 E to the 0.025 times 5. Right? And so now, with continuous compounding, your money really grew, and you're now up to $5,665.74. Much better. You made 73 cents more. Don't spend it all in one place. Yes?
Does this T have to be in years?
Yes.
Okay.
Just like my other equation with when we tell you about exponential growth or decay, T here will be in years. Right?
So what is the difference between these two?
Basically, your money is always growing here. That's what it means by continuous compounding. Okay? So the other one, it's only being compounded every month. Okay? Okay? So you think about things that are compounded and the way things work. You think about your credit cards, car loans, mortgages, student loans.
Try not to think about that.
You get the press, right? But if you have a credit card and you get your statement from the credit card company, and they say, well, we only want $25 from you for your monthly payment, don't just send them $25. Okay? You want to give them basically as much as you can. Because the credit card company would love it very much as all you did is every time just send them a minimum payment. Because they'll make a whole lot of money off you. So you want to pay them off as quickly as you can. And then get rid of those credit cards that you may have that are at very high interest rates. So store credit cards are the worst. Have the higher rates. Visa and MasterCard will be lower. Of course, all that depends on your credit score, okay? How much it will be. But you get store credit cards that are basically probably somewhere in the 20-some-odd% APR. Okay. The other thing about those is you go to, let's say you go to Best Buy or whatever, you decide you need to have the latest and greatest computer or flat screen TV, and you go to the store and they have those offers that say 6 months same as cash, giving you the Best Buy credit card. Okay. Well, the way those work is you need to make sure you pay off the entire balance by the 6 months, the 18 months, whatever it may be. If you don't, they will charge you the interest from day one. Okay? And again, for a store credit card, you're talking on the order of 25%. So if you do those things, you do need to make sure you basically, what you want to do is plan out that you're going to make a monthly payment or whatever, such that you will pay it off in the term of that special offer. Okay. Let's see, other things you should be able to do in terms of, we did all that, did that. Drawing graphs we talked about. Let's say I had something like this. Let's say y equals and I want to know what is so you're thinking in terms of what we just did last week, or even on today's quiz. So, what happens to this as x goes to infinity? It goes to infinity, right? So as x goes to infinity, my function is going to, so as x goes to infinity, y is going to go to infinity, right? All right, well, how about as x goes to negative infinity? What happens to y?
Positive?
No? What's going to happen to y? No, not zero.
Go to zero.
Goes to 3.
Goes to 3. Remember, after all, 2 to a negative exponent means basically as that exponent gets larger and larger and negative, it's basically going to 0, right? So that first term is barely going to go away. I'm left with the 3. When we're talking, you know, if I do what is 2 to the negative 2 million, it's basically 0. Okay? It won't quite be, but it's basically 0. After all, it's 1 over 2 to the 2 million power. Okay?
So if that was 2 to the x plus or minus 3?
Then it'd be minus 3. Yeah. Whatever that number is. Because again, that 2 to the x term goes away when x goes to negative infinity. Okay? Okay? So that term disappears as, okay? Other stuff. What if I had something like this? Let's do, we said that the natural log of e to the 7th was going to be 7, right? We said natural log and e cancel each other out. Okay? How about e to the natural log of 5? What's that going to give me? Well, it works exactly the same way. I get 5, because again, e and natural log are opposites of each other. Right? All right? On the toy, what is the log of 10? And this is now the LOG button on the toy. It's 1. Right? What is the log of 100?
Two.
It's 2. Here's a tricky one. Without the toy, what is the log of 1,000? 3. Very good. What did I ask you to find on the toy? Again, logarithms give you exponents. So the value I want to know is 10 to what power is 100? That is 10 squared. 10 to what power is 1,000? That is 3. Okay. So when there is no number down here, then it's assumed to be base 10. Okay? And then natural log is always base e. Okay? In terms of logarithms. But you can do logarithms based on whatever base you want. Okay? As far as that's concerned. Right? Well, how about this? What is the log of 10 to the 8th? Okay. You can plug in the toy if you have to. What?
8.
It is 8. Okay. Again, log and the 10 will cancel each other out, and you end up with the 8. Just like the natural log and e cancel each other out. All right. What about this? What is the log base 7 of 7? It'll be 1. Okay? If these two numbers match, right? Right? Okay. What is the log base 3 of the square root of 3? Okay?
That's still 1.
No? Well, so first off, I can write any radical in terms of an exponent. So this becomes log base 3 of 3 to the 1/2. So square roots is the same as doing an exponent of 1/2. Cube root would be 1/3 and so on. Okay? So now if I do this, I just end up with 1/2. Okay? So any radical can be written in terms of an exponent. Right? And so just in terms of that, so for example, if I had the 4th root of x to the 9th, I want to know what is that in terms of an exponent. I get the x. You got that the root number goes here, and then this number will go there. Right? So the 4th root of x to the 9th, in terms of an exponent, becomes x to the 9/4. Right? Now, in terms of that notation, the only one where we don't write a number out front is when we're talking square roots. then we don't put a number up front. But if we did, it would have been a 2, okay? But it's the only time you do not put a number up there associated with the radical, okay?
So that's how you write that, like, whatever the numbers,
Yeah.
doesn't matter what the numbers are.
Whatever the numbers are,
You always
that's how they
write
go.
that.
So given a radical, you can change it to an exponent. Okay? So for example, now, if I have one like this, what is the log base 9 of the 8th root of 9 to the 5th? Yeah. Well, I can first rewrite it and get rid of the radical. Okay? And once I get that, then it's easy. And we end up with what? 5/8.
What's the base, what's the log base 9? What is the base 9? What information is that telling us?
We're talking in regards to 9s, okay? So basically in terms of, I think in terms of 9s, 9 at the first is 9, 9 squared is 1, and so on.
Oh,
Okay?
I see. what
You
you're
can do log any base.
Okay.
Again, the only 2 you can do on the toy directly are log base 10 and natural log.
saying.
Okay? We'll talk about that, even with that on the toy, you can actually find the log of anything.
So then, how did we end up with 5/8?
Because I can rewrite this based on what I had over there.
Right,
We end up the log base 9 of 9
yeah,
to the 5/8.
yes,
And I said if these 2 numbers match,
that's fine.
they go away. We're left with 5/8. Okay?
What if they're not the same?
Then it's a different problem.
Okay.
And you need a calculator.
We'll say that for next week. All right? All right. Good. All right. All right. So there's one last thing for the day. Again, the notes will be posted on the website. The video will probably show up there sometime tomorrow. Just because of process time it takes.